Hey everyone, welcome back to Roboarmy. This time we are going to build a fun and interesting mini game project using an ESP32 and SH1106 OLED display. In this project, we will make the classic T-Rex Dino Jump game. The dinosaur will run on the OLED display. Obstacle will come from the front, and when we press the push button, the dinosaur will jump. We are also using a buzzer in this project so we can add sound effects when the dinosaur jumps or when the game responds. So let's get started. Here what we will need for this project: ESP32 development board, SH1106 OLED display, push button, buzzer, breadboard, jumper wires. Now let's start by setting up the connections. First, connect the SH1106 OLED display with the ESP32. The OLED display works on I2C communication. Connect OLED VCC to ESP32 3.3V, OLED GND to ESP32 GND, OLED SDA to GPIO21, OLED SCL to GPIO22. In our code, GPIO21 is used as the SDA pin and GPIO22 is used as a SCL pin. Now connect the push button. Connect one side of the push button to GPIO27 of the ESP32. Connect the other side of the push button to GND. We are using the ESP32 internal pull-up resistors, so we do not need any external resistor for the push button. Now connect the buzzer. Connect the positive pin of the buzzer to GPIO12. Connect the negative pin of the buzzer to GND. The buzzer is used for sound feedback in the game. Now before powering the circuit, double check all the connection carefully. Now download the code files given in the description below of this video. Now open the code. Let's understand how this code works. First, we include the Arduino library. This library gives us the basic Arduino functions like pin mode, digital read, digital write, setup and loop. Then we include the wire library. Wire library is used for I2C communication. Our SH1106 OLED display communicates with the ESP32 using I2C. After that, we define the OLED pins. Trex underscore SD underscore pin is set to GPIO21. Trex underscore SCL underscore pin is to set to GPIO22. Now these pins are used to communicate with the OLED display. Next we define the push button pin. Game underscore button underscore pin is set to GPIO27. This means our jump button is connected to GPIO27. Now in this code, the original T-Rex game file uses the name touch underscore sensor underscore pin internally. But in our circuit, we are not using a touch sensor. We are using a normal push button. So we map touch underscore sensor underscore pin to game underscore button underscore pin. This means whenever T-Rex game code checks the touch sensor pin, it will actually read our push button pin. So next we define button underscore active underscore high as 0. This tells the game logic that our button is not active high. Our button is active low because we are using input underscore pull up. So when the button is pressed, the ESP32 reads low. Now we define the buzzer pin. Buzzer underscore pin is set to GPIO12. Now this pin controls the buzzer sound. After this, we include the main game header file. T-Rex-Dino.h. This file contains the actual T-Rex game logic. Inside this file, the dinosaur graphics, obstacle movement, jump logic, score system, collision detection and display drawing functions are handled. Now let's understand the setup function. The setup function runs only once when the ESP32 starts. First, we start serial communication at 115200 baud rate. This helps us debug the project using the serial monitor. Then we start I2C communication using where.begin function 2122. This tells the ESP32 that SDA is connected to GPIO21 and SCL is connected to GPIO22. Then we set the I2C clock speed to 400 kHz. This makes the OLED display update faster and smoother. After that, we set the push button pin as input underscore pull up. This activates the ESP32 internal pull up resistor. So the button pin stays high normally and below low when the button is pressed. Then we set the buzzer pin as output. After that, we call no tone on the buzzer pin, so the buzzer stays silent when the game starts. Now finally, we call Dino underscore enter function. This function starts or initializes the T-Rex game. It prepares the display, loads the game graphics and gets the game ready to run. Now let's understand the loop function. The loop function runs again and again continuously. Inside the loop we call run Dino game function. This function runs the complete game. It checks the button input. When we press the button, the dinosaur jumps. It moves the obstacle from right to left. It updates the score. It checks whether the dinosaur hits any obstacle. It also refreshes the OLED display again and again to create animation. Now let's understand how the dinosaur is created on the OLED display. The OLED display is made of tiny dots called pixels. Each pixel can be turned on or off. When many pixels are turned on in a proper shape, we can create images like a dinosaur, cactus, ground line, text. The dinosaur in this project is created using pixel art. Pixel art means we design the dinosaur using small square pixels. Inside the T-Rex game header file, the dinosaur image is usually stored as a bitmap. A bitmap is like a small pattern of ones and zeros. In simple words, 1 means the pixel will turn on, 0 means the pixel will stay off. For example, if we want to draw the dinosaur's head, body, legs and tail, we decide which pixel should we on and which pixel should we off. The OLED library then reads the pixel pattern and draws it on the display. So the dinosaur is not a normal image like a JPEG or PNG. It's a small black and white pixel design created using a bitmap array. This is why the dinosaur looks sharp and simple on the OLED display. The same method is used for obstacle like cactus. Each obstacle is also made using pixels. When the game runs, the code keeps changing the position of these pixel drawings. This creates a running animation. For example, dinosaur stays on the left side of the screen, the cactus starts from the right side. Then the cactus position keeps decreasing, so it moves from right to left. When the button is pressed, the dinosaur Y position changes. That makes the dinosaur move upward and then come back down. This creates the jump effect. The game also checks for collision. Now collision means the code checks if the dinosaur pixel and the cactus pixel are too close to each other. If they touch or overlap, the game is over. So in this project, the OLED display, pixel graphics, button input and game logic work together to create a complete mini game. Now let's upload the code. In Arduino IDE, select the correct board. For most ESP32 boards, select board ESP32 Dev module. Then select the correct COM port. Now click upload. After uploading, the OLED display will start showing the T-Rex game. When the game starts, the dinosaur will appear on the display. The obstacle will start moving toward the dinosaur. Now press the push button, the dinosaur should jump. If the timing is correct, the dinosaur will jump over the obstacle. If the dinosaur hits the obstacle, the game will stop or restart depending on the game logic inside the T-Rex file. The buzzer will also give sound feedback according to the game response. And that's it. You can also modify this project by changing the dinosaur design, obstacle design, jump speed, game speed, or adding Roboarmy banding on the start screen. We hope you found this tutorial helpful. Thanks for watching and keep building with Roboarmy.
Roboarmy. One-stop global community for teens in robotics and AI.